The notes can be downloaded in the Google Classroom. Now, this is a new chapter called Matrices and Determinants. Now, these are very, very new concepts in mathematics. So every time when we need to learn a new concept, there is always a need. In this case, why do we need to learn matrix? This is because sometimes when we deal with some problems, using numbers is just not enough. You can say, oh, we have so many different numbers. Why is it not enough? It's not enough. A rational number is not enough. Real number is not enough. Complex numbers sometimes even not enough. I'll give you one example. It's not just limited to this one example. There are many, many other ways that numbers are not enough. Now, in this case, when you see a graph on the left, this is also an example from the textbook. This is a graph on the left. And A, B, C, D, E, perhaps in this case, are just 5 cities. And the red arrows represents maybe the connection within them. For example, there is a way to go from A to B. There is a way to go from B to D. Just like the connections, if there is one. And then you can see that there is no way to go from B to E directly. Okay? And this is a kind of a network showing as a graph. Now, graph is a very intuitive way when we learn the connection. But in this case, using numbers to represent this graph is not very good. I mean, numbers alone is not enough. So that's why we have to, that's why we have to create a group of numbers like this. Okay, a group of numbers like this. And then use some number inside to represent the connection. For example, here you can see from A to B, right? And the number is 1. That means there is a way to go from A to B. And from B to C, you see, the number is 1. That means there is a way to go from B to C. Also B to D, you see? B to D. This is B to A to B, B to C, B to D. So if there is no connection, then I simply use 0. Okay? So after we construct this group of numbers, this group of numbers can represent the graph, can also represent the connection very well. And this group of numbers is something new. It's the new concept we learn. It's called a matrix. This group, one number is not, but this group is called a matrix. Okay. Now, in our curriculum, we are not going to explore too much about the usage of the matrix, but we are going to learn how to manipulate, meaning how to add, how to multiply, how to subtract. Now, these basics about matrix. Any questions? Now we will start really now. We will start now. Now for the matrix, there are basic concepts. Today we have a lot of basic concepts. You try to remember them. Try to wire them into your head when I explain. Now the matrix is a rectangular array of numbers. They line up like this. They line up like this. They have this is called a row and a column. It's just they line up like this. It's like a square of numbers. Now, if you don't, sometimes if you are lazy, you can write Aij, and then you write m times n. You can use this bracket. You can also use these brackets. Either way, you can see this one is a small bracket. This one is a square bracket. It doesn't matter. We know that you're writing a matrix. Okay, now let me further explain what does Ij mean and what does m times m mean. So in the matrix, we have rows and columns, and we have to count the rows and columns. For example, this matrix, it has 4 rows and 3 columns. 1, 2, 3, 4, 1, 2, 3. So this m times m, also called order, is 4 times 3. And this one is the opposite. This one has 3 rows and 4 columns, and this one is a 3 times 4 matrix. So when we say what times what, it means the order. In other words, the size. But we say order, the order of matrix. Okay? For example, this is a simple, I think it's a simple idea. For example, can you state the order of these following matrix? For the first one, you can count. This is 1, that's 1, 1 row, and then 2, 1 times 2. For this one, it's 1, 2, 3, and 1. And for this one, it's 1, 2, 1, 2, 3, 4. Remember, you cannot swap the rows and column. You must first count the rows and then count the column. Is that okay? So you know what m times n mean. The other thing is Ij. What does Ij mean? In this notation, what does Ij mean? Now, Ij means one of them. For example, Aij means one of them. One of the numbers is called an element, or simply entry. We use element. One of them is called the element, and we need to number the element so that we know where it is. So Aij is the ith row, the jth column. For example, A11 is the first row, first column. A21 is the second row, first column. A12 and A21 are not the same necessarily. A12 is the first row, the second column. Okay, so Ij means the position. It's like a coordinate, but not. We count from the left top and then count down and count to the right. So this first one is A11. Is that okay? I hope so. It's not too much. Basically, it's just this notation, and you know that these are all numbers, and then they have a mark on them, so we can find where they are. Any questions? If no, let's move on. Now we'll quickly enter the realm of calculating very soon. So now, if we have 2 or more matrices, how do we know if they're equal or not? You have to really be careful before you call them equal. So 2 matrices are equal. It has to satisfy these conditions. They must have the same order. And also every corresponding entry, every corresponding element, position by position, are equal. So example 1, it's a simple example. You see, this is a 3 times 2. This is also 3 times 2. right? They are of the same order. And these two matrices are equal, A and B. Oh, by the way, we use the English letter, the capital letter, to represent matrix very often. So A equal B, matrix equal matrix. And then can we find these? It's very simple once you know. Since they are equal, then we can line them up position by position. So m plus 1 equal -2, m equals 3, n equals 0, p plus q equal 5, and also 2q minus 1 equals 3. So that means 2 and 3. Okay, that's the equal concept. Equal concept. Now 1 minute, you finish this. An equal matrix. Find some of the unknowns inside. Is it fine? I hope it's okay. It's a very new concept, but the calculation is not hard once you know what it is. Okay? So that is part of the basics. Now we come to this. It's a group of names. So you need to follow closely. Okay? You need to, because we're going to use these in the future very often. The first concept is called a row matrix. This means that this matrix is very short. I mean, the length is very short. It only has one row. Okay? For example, I will give you an example. For example, 1, 2, 3, that's a row matrix. 0, 1, sorry, I shouldn't write the comma. If you write comma, it looks like a coordinate. But if you don't write comma, that's a matrix. Okay. This is a 1 by 3. This is a 1 by 2 row matrix. And there is also something called a column matrix. Column matrix is a very thin matrix. It only has one column. For example, 1, 2, 4, -1, 2, 5, 8. These are column matrix. Zero matrix, null matrix, they are the same. I don't know what the size is. These are all zero matrices. If all the entries are 0, then they are zero matrix. Zero matrix has different sizes. Okay. Now, sometimes we get tired of writing all the zeros. We just use a very dark 0 to represent this matrix. If we use the dark 0, it means a matrix that is all 0. Later on, you will see it, not in today's lesson, but in the homework. Dark 0. The next one is a square matrix. A square matrix is like a just look like a square. Okay, when you write it, look like a square because the rows equal the columns. Now this is 1 by 1 matrix. Now some students got confused. 1 by 1 matrix, isn't that a number? You can say, I don't think so. I don't think so. It's as simple as a number, but it's a matrix. Okay. Now this is a 2 by 2. This is a 3 by 3. Of course, we have 4 by 4, 5 by 5, and so on. So these are square matrix. And we deal with square matrix very often. Not necessarily, not all the time, but very often. Square matrix. The next one is called a diagonal matrix. A diagonal matrix is a square matrix that's the first condition. It is one of the square matrix, and also outside the principal diagonal. I need to explain what principal diagonal is. So in the square matrix, there is this diagonal. This one is just itself. This one is a diagonal from the left, top left to the right corner. So for 1 by 1 square matrix, there's only one number. For 2 by 2, there are two numbers. For 3 by 3, three numbers. These numbers, they are the principal diagonal. Okay? Now later on, you will find out that these numbers on the principal diagonal are very special. So on the principal diagonal, these numbers that we deal with most. And if that outside the principal diagonal, all the other numbers are 0, then it's a diagonal matrix. Meaning only principal diagonal has values, has non-zero numbers like that. All the other places must be 0. Okay? I'll give you another example. -1, 0, 1, 0. That's also a diagonal matrix. Another one will be 0, 0, 0, 0, 3, 0, 0, 0, 5. This is also a diagonal matrix. Now, remember, diagonal matrix doesn't mean that the diagonal is not 0. The diagonal can, one of them or two of them can be 0. It's just the outside the diagonal, it must be 0. Now, diagonal matrix is very simple to use. Right now, I cannot tell you why it's simple, but diagonal matrix is simple to use, simple to do things, simple to add, simple to write, simple to multiply, basically. So in the future, you will see that we will try to simplify, in a way, simplify a lot of matrix to diagonal matrix in order to move on. But that's for the future. Okay, remember diagonal matrix. The next one is even more special. This one is called an identity matrix, or called unit matrix. Now this matrix is very, very special because it can be almost determined what it looks like once the order is given, once how many rows, how many columns are given. Because an identity matrix is a diagonal matrix for sure. It's already diagonal. And not just that, it also requires that all the diagonal numbers are 1. So if you think, diagonal matrix, diagonal matrix are very special, this is even more special. This one, that you already know what they are on the diagonal, and the other places are all 0. Right? So I say, oh, can you write a 3 by 3 identity matrix? That's simple. You can only write this one. That's the only identity matrix of 3 by 3. Whereas if you are asked to write the diagonal matrix of 3 by 3, you can write quite a lot of them. They're all different. Is that okay? Now, the meaning and the importance of identity matrix. Right now, I can only tell you that it's as important and as essential as the number one we have in real numbers. You see, 1 is very special. 1 is the first number, right? 1 is the first number in the number system. Identity matrix is like 1. Is like 1. It's like the first matrix in the matrix system. Okay, but because matrix has different sizes, so we not just have only 1, we have different size identity matrix. Okay, so that is also very important. Now in the future, we often get tired of writing all the numbers out. So if you want to write identical matrix, you just write I. Okay, you just write I. And then if you want to indicate the size, you just say, oh, for example, this one is I 1 by 1, this one is I 2 by 2. If you want to point out, oh, this is not the others, this is this one, then you point out the size. But I use the letter I. Okay, so you see I and it's a matrix, it must be this. Is that okay? Any questions? Any questions? No. There are so many different things, huh? But I think you can kind of get the meaning from the name. What's a row? What's a column? What's zero, right? What's square, right? Like maybe the diagonal matrix, you have to remember, oh, it's this diagonal, not the other diagonal. It's this one, not this one. And identity matrix, you also have to like get it into your head, because if you are new to this, you wouldn't think that, oh, this one is special, right? You wouldn't think, oh, why must I study this matrix? And why must I call this one I can call any other, because all of them are new to you, so you don't know which one is special. And I point out to you that this one is special. So you have to remember this identity matrix.
I'm sorry, Ms. Chen, I have a question. May I know whether open bracket 0, close bracket is considered as a diagonal matrix?
Which one?
Just a 0.
You mean the zero matrix is a diagonal matrix? I think it is.
Thank you.
Zero matrix? No. It has to be a square matrix first.
But just a 0, like only one number.
I think so. As long as it's square, and as long as all the other things are 0. In this case, you say, what about this matrix, right? This matrix is very simple, and the diagonal is just itself. It doesn't have any other numbers other than diagonal. So I guess it is. Okay, I think you can consider it as diagonal matrix. Okay, and so as this one, if you ask, this one can also be considered as a diagonal matrix. It's that when matrix is reduced to a number, then it's just as, when matrix is reduced as number, then it's just as simple as numbers. So it really is not necessary for us to address this that much. But if you ask, yes, yes, it still is. Okay, diagonal matrix. It's too simple. It doesn't even look like one, but it is. Okay. I understand. New concepts are scary. It is. It is. But right now, it's not so bad. It's not so bad. You can imagine there are a group of numbers you have to just do something with them. Now, these are not square matrix, so it's not anything. The diagonal for this one, there doesn't have diagonal. Okay. That's the first lesson. Any question? Now, some students are late to the lesson, so I suggest that you watch back. You watch back the video, the recording. Is that okay? We'll move on then. Now, this is a second file in the Google Classroom. Now, you can go to the Google Classroom for downloading. Is it fine? I'll just continue now. I'll continue now. You know that there's a new group of things. They're called matrix, right? And then you know the names, how you call them, how you write them, right? And we quickly enter the math aspect. It's all math, but this is like the math that you know most. That is to operate on them. The operation of matrix is can get very complicated in the end, but fortunately, today's lesson, the operations, all of them are manageable. I mean manageable during the lesson. Okay. Today we're going to cover three operations. I think there are altogether five operations. Today we cover the first three. The first one is to add. So if you want to add matrix to another matrix, you must make sure that they are of the same order. Not order. And we will add the corresponding elements resulting in the sum of the same order. It reads like, I don't know what they're talking about, but it means that when you add, you have to make sure that if you're adding, this is 1, 0, 2, 0. If you want to add, you must add A, B, C, D, and then they can add. Okay. Now, if you want to add 1, 2, 0, 0 to like a number, let's say 100, then it's not equal to anything. You cannot add a matrix to another number. You cannot add matrix of different sizes. It just doesn't work. It's called undefined. Okay. And then once it's defined, it's very simple. So in this case, if I want to add example 2, if in this case I want to add, this is 3 by 2, 3 by 2. I add them, I'll just add each position. This one is 1, this one is -3, 6, 1, -1, 8. Okay. And then if I want to add C to B, it doesn't work because the order of C is 2 times 3, 2 times 3. The order of B is 3 times 2. Therefore, it's undefined. That's it. That's addition learned. Fine. Now, another example, you will see that I have 2 by 2, right? 2 by 2, 2 by 2, 2 by 2. So I can add. Now I know that A plus B equals C. So A plus B, I'll add A plus B equals C. This is A plus B. This is C. If they're equal, then I can set up equation to find M and PQ. For example, -1 plus P equal 1, P equal 2. 1 minus Q equal -2, Q equal 3. M plus Q equal 4, M plus Q equal 4, N equal 1, and M plus N equal 0, M equal -1. Is that fine? Now in this example, I not only use the addition of matrix, which is very simple. The addition of matrix happened here. Addition. I also use the equality of matrix, which happened here. Equality. What is to add? What is to equal? Any questions? If no question, let's quickly learn the second operation, that is to subtract. To subtract, it's the same as to add. Same order, same order. The outcome is also a matrix of the same order. If not the same order, cannot do. Cannot do. Example. What is B minus A? So I copy B. Now this is also sometimes an issue, is that some of the students don't like to copy. You copy. You don't do this. You don't do it here. You copy and then you subtract. 2, 0, 5, 8. Okay. I know it's a lot of writing, but you must do so. During the lesson, I type it out for you, so you can maybe catch up quicker. You can spend more time listening, more time asking questions. But when you're solving the problem, you're presenting your ideas, you have to write it out. I know, but you have to learn to write it out. So this one, you just put C plus bracket B minus A, because we already know the result of B minus A. And then I will put B minus A here. And then I will do an addition. So this is -3, -4, 7, 11. Is that okay? Now, I also recommend that you have a certain way of doing the addition. Now, for example, you have to form a habit that, you do the first one and then you do the second one, like going this way. You either go this way or go this way, or you go this way, but don't mess it up. Don't mess it up. The first question is a subtraction. The second is a mixed operation of addition and subtraction. Here I put down a little question here. This is a question by me. Because you can see that this is a mixed operation and it has addition, subtraction. Now, one problem that we need to solve in this chapter, and I emphasize, in this chapter, you have to have this mindset that anything that you do in the past, for example, you just do something. For example, there is a bracket that some people will say, oh, I will do without the bracket, meaning that I will do C in order to find out this, I will rather find out this and then this. Meaning that, what if I break the bracket? Right? What if I do this one first and then do the subtraction later? Will the answer be the same? Now, in the past, we know it's the same, because if we're dealing with numbers, it's obviously the same. We know that we can swap the operation. we can do this first and the second. We know that. But for matrix, you have to think now. You have to think now. If I break the bracket and do the addition first and then the subtraction next, will the answer be the same? Because later on in the second half of our lesson, we will address this. We will talk about this in detail. One thing is that you will find out that in the future lessons, that matrix operates very differently from numbers. It does not obey all the algebraic rule that you learned in the past. It doesn't mean that it doesn't obey some of them. It does, but not all of them, which is very dangerous. So you think, have an idea. What if you do this first? Will the answer be the same? Now, no confirmative answer, but later on I will tell you. Okay? So I guess there is no problem with addition and subtraction. The third one, I think you know, oh, we're going to learn multiplication now. Yes, multiplication is the third one. Third one is called a scalar multiplication. Yes, it's one kind of multiplication. That is when we have a number and a matrix, I want to multiply them, which is, I think it's kind of weird though. Wow. A number and a matrix, I can multiply. Is that okay? That we're not talking about matrix multiply matrix. We're talking about a number multiply matrix, and the result is simple. So you have a matrix. Perhaps in this case, I don't need another matrix. I only need one matrix. So if you have a matrix and then you have a number, how do you multiply? You just multiply every single one element. Multiply every single one element inside the matrix. And then you get another matrix. Is that okay? Now, please know that negative A means negative 1 times A. I think that's fine. A here is a matrix. Okay. Now, let's practice the scalar multiplication. A, B, C are matrices. 4 is a number. So that is a scalar multiplication. How do I multiply? I just multiply. You write it out. You write it out and then you multiply like this. You multiply every single one. Now, how about a fraction? A fraction is a division. It's not a, like you see, this is divided by 6, but you don't say it's not division. It's a fraction multiply. Multiply, and then you multiply every single one. If you want to use calculator, that's up to you. But can you really speed it up that much? I don't think so. Because every multiplication is 6 multiplication. And you have to do it carefully. Otherwise, it's not going to work. Now, this is a mixed operation because you are doing a the scalar multiplication and subtraction. So scalar multiplication first. You write it out. In your homework, you write it out. And then you multiply. And then you subtract. Okay. Now, finally, you need to do another multiplication, another scalar multiplication. So you put it in. And then you multiply each one. Okay. Now, this means that whenever you do one exercise, you need a large piece of paper to write down all the steps, and it's necessary. Is that fine? It's not difficult. It's just long. Any questions? We only have one example. And I didn't give you a classwork. I think you can do without the class. You can understand how to add, how to subtract, how to scale and multiply without an exercise. Am I right? I hope so. I hope so. If you have any difficulty, you let me know. Don't be shy. This is a new thing. You can have all sorts of different questions. Now, let's learn the three operations as a group. Now, let's talk about them together and see if when we mix them, what will happen. When we mix them, what will happen? When we mix them, and then we want to simplify, we want to do it quicker, right? So there are things that we can do and the things we cannot do. In this case, there are a lot of things we can do. They are called the properties of the operations. Please note that capital letter A, B, C, they are matrices. They are matrices of the same size, same order, M by N, M by N. Now, 0, this is dark 0, do you see? Dark 0 is not a number. Dark 0 is not a number. Dark 0 is a matrix of the same order. Now, here, these two weird letters, lambda and mu, lambda and mu, they are Greek letters. Because in this chapter, we cannot only use, if we only use English letters, it's not enough. Sometimes C and C, if you use capital letter C and the small letter C, one representing the matrix, one representing the number, I don't think you can distinguish. So we have a complete different some other thing, the Greek letters to represent numbers now. It says they are two scalars. Scalars are numbers. Why do we just say numbers? Some people ask, Ms. Chen, why don't you just say numbers? Why do you say scalars? That's because when we talk about matrix and all the other things that we learned before, right? Matrix is new and the other things are all scalars. Is it fine? All the things we learned in the past, they're not matrix, they're scalars. So scalars, you can see, numbers, numbers. And then we can add, right? Now, if these looks like, you feel like, oh, it's very obvious, then we don't have to prove it. Is it fine? In the textbook, you can find each single one, A, B, C, D, F, G, H, A, B, C, D, F, G, H. All of them, every single one, you have a proof that, they are equal. But if you feel, oh, this is too very obvious, then we don't prove it. First is A plus B equal B plus A. I'll use an example. 1, 2, 3, 4 plus 5, 6, 7, 8. And then 5, 6, 7, 8 plus 1, 2, 3, 4 Don't you think the answer should be equal? Right? So I think this is obvious, right? Another thing is that this is associative property, meaning that, oh, you can do this first or you can do this first. It doesn't affect the final answer. It's very true in numbers, in scalars, it's very true. Is it still true in matrix? The answer is yes. The answer is yes. For example, you have 1, 2, 3, 4 plus 5, 6, 7, 8 plus 9, 10, 11, 12. If you think, oh, do I do this first or do I do this first? Are they equal? Now, I know I'm talking. If you think what I'm saying now is too obvious, and that's fine, but you have to go through. This is mathematical thinking, is to not to assume anything, and you have to have that mindset. Don't assume that, oh, it's obviously equal. It's not obvious. This is a new object. It's like an alien. You need to study it. We're human. We know that, oh, you are walking upright. You have a lung. You can breathe. You have a mouth. You can talk. That cannot be assumed when you go outside and meet another kind of civilization. It's a new thing. It's an alien thing that you have to study from the very beginning. Does it have a lung? Can it breathe? Does it drink water? All that you cannot assume what we do is normal for these things. For these things may change. Okay. So this is obviously associative property. Obviously, it's true. It's true. I don't prove it, but you can see. The next one is addition. A plus 0. 0 is not number. 0 is a matrix. It's dark 0. A plus dark 0. Do you think it's equal A, right? 1, 2, 3, 4 plus dark 0, right? Right? Isn't it equal to itself? The answer is yes. The fourth one, D. A plus negative A. Is it equal to dark 0? You can think about it, right? What is negative A? Just now I point out what's negative A. Negative A is just A times negative 1. So do you think it's equal dark 0? If it is, then you say, oh, this is something. This alien also walk with 2 feet. This alien also drink water, basically. The next one is a mixed operation, because it has, this is a scalar multiplication. This is another scalar multiplication. This is a normal multiplication and a scalar multiplication. Are they equal? Are the results equal? Right? Use an example. Here's an example. For example, mu is 2, and then lambda is 2, and mu is 3, and then A is 1, 2, 3, 4. Okay? And that is, the other one is 2 times 3 first. 2 times 3, and then 1, 2, 3, 4. These are numbers, okay? That's 6 times 1, 2, 3, 4. Do you think this result and this result are equal? Meaning that, oh, you multiply 3 first and then multiply 2. Is it equal to you directly multiply 6? Right? And you can see that I think it's equal. I think it's even more, you can swap mu and the lambda. You can swap 2 and 3 in this case. You can multiply 2 first and then multiply 3. It does not change the answer. Now for scalars, in the past, for numbers, it's obviously true, but for matrix, we learn again. We learn again. So this matrix has a lot of things in common with numbers, basically. Still, it doesn't look like it's very strange, but still, it can add in this way, it can swap in this way, it can associate in this way, all that. F, that is a mixed operation, which is there is an addition with the numbers or subtraction, addition or subtraction, and then multiply a matrix. Can I multiply the matrix first and then do the addition? This is called a distributive property. In the numbers, obviously it's true. In numbers, obviously it's true. Is it true in matrix? The answer is yes. You can do the addition first and then multiply. You can do the multiply first and then add. Does not change the answer. The next one is a different kind of distributive property. Distributive property, different kind. Because here I have an addition of matrices and then multiply a number. So is it equal to I multiply the number first and then adding the matrices? The answer is yes. If you feel, oh, I don't see why they are equal, you can give yourself a numerical example to look at it and you can see they're equal. I think in our case, that is almost too often that you think that obviously they are equal and sometimes they're not. I think it's that the mistake is that for matrix, you always assume that, oh, obviously it's equal. Why can't I swap why can't I swap them? Why can't I change the order of the operation? Usually you assume too much rather than too little. So in this case, yes, you can expand them. This is called expansion. The property is called distributive property. Okay, and you can do that with numbers. You can distribute. You can also distribute matrices. These two are different. Do you see? Please note that they're different. F and G, they're not the same. The last one is H. Now, H is also very confusing because in this one thing, it has dark 0 and not dark 0, normal 0 and dark 0. Now, normal 0 times a matrix equal to a dark 0. I think you can understand that. 0 times 1, 2, 3, 4 equals 0, 0, 0, 0. That's a dark 0, right? And this is a normal 0. On the left is a normal 0, scalar 0. On the right is a dark 0. And the second equation is that lambda times dark 0 equal dark 0. I think so. Lambda is a number times dark 0 equal dark 0. I think so. So this is also something in numbers. I think it's very, very easy that 0 times A equals 0, right? And B times 0 equals 0. In numbers, it's very obvious. And in matrix, you just have to recognize it. Oh, it's equal. It's equal. Is it fine? I know it's a lot, but it's a lot and mixed with something, it's obvious, and also some skepticism, maybe something else is not okay. Right now we haven't encountered anything that is distinguish the matrix very much from the numbers. Right now, matrix behave very much like a number. Don't you think so? Right now, they add the same way, they subtract the same way, they multiply the same way. It looks like a number. So when we do that, we just make sure that we're doing everything correctly. Example 6. So A is a matrix, C is a matrix. Find matrix B. There is a B inside. Find matrix B. How do I do that? First, I will take this algebra. That is A plus 2B equal 3C. And I learn maybe I can change subject. I can change subject. Now, how do I change subject? I will, in the past, if these are numbers, I will just transport terms. Now you can transport terms. Can you? That means I will first have to change it to 2B plus A. Okay. And I know I can do that. And then I will, if I want to transport terms, I will minus A. And then I will know that, oh, this is actually associative. And then this is actually dot 0. This is dot 0. And finally, I succeed in transporting this one matrix to the right. Now, if I want to make B the subject, I must move A to the right-hand side. And how do I do that? First, I will swap them. And the property here says that I can, property A says that I can swap them. So I can swap. Okay. And then I will subtract A on both sides. That's just good sense. That's just good sense. And then after I subtract, I will associate. Now remember here, I said that I can put a bracket any places, right? Property B says that I can put a bracket any places. And here I'm putting a bracket here. That's called associate. Associate these two. Do these two first. And then these two will get 0, dot 0. And we also, from the property, we know that the dot 0 plus A equal A. So here, dot A, dot 0 plus 2B equal B. So after 1, 2, 3, 4, 5, after 5 steps, I successfully transferred A to the other side. What's your comment? Any comment? Sophie, what's your comment?
I think it's a little bit complex to do a lot of steps like this, but it's kind of easy. But I have a question, like, can we do it directly without making
Not
lot
for
of
the first time. For the first example, I want you to see that it's actually this complicated when you want to transfer a term. But in your homework, you can do it in one step. Is that okay?
Okay, thank you, Ms. Chen.
So if you read the textbook, it's the same. You have to think in your head, oh, how can you transfer A? How can you? Then you have to think about all the properties that's obvious. The problem is that these are too obvious. So you don't recognize that, oh, they are there. You always forget them until you meet something new. So far, we don't have anything new. That's why you can use it safely, relative terms, safely. So in the homework, you can do it in one step. That's to transporting the term. But in reality, in the learning process, you must learn, oh, this is new, this is new, this is new. Because these are not numbers. These are aliens, okay? Is it fine? Now I'm going to divide 2 on both sides. Now with the divide 2 on both sides, I have a lot to say. So dividing, that means 1 over 2 times 2b equal 1 over 2 times 3c minus 8. Okay, if I want to divide 2, this is what I do. I need to multiply. And then I need to associate. Okay, and then finally b equal 1 over 2 times 3c minus 8. Also, now when you want to divide 2, it's not just simply divide 2. You must think about these things. This one, e. You see, when you have 1 over 2 here, can I multiply 1 over 2 and 2 first? Yes, you can. You see here, lambda and mu. Because in my operation is mu times b first and then lambda. Can you do lambda times mu first? Yes, you can. So that's why you can divide. In your homework, you don't have to write this. In your homework, you don't have to write this. But during the lesson, you must know that the reason we can divide 2, perhaps I shouldn't say divide 2. The reason we can multiply 1 over 2 on both sides to eliminate the coefficient of b is because of the property E. Okay? Now you have this, and then you figure out, oh, now I have b equal this, I figure out. Oh, what is it? I will do the multiplication. Again, a lot of writing, a lot of writing. Okay? And then the subtraction. Okay? And lastly, a multiplication. And then you're done. Okay? So this question is 2 parts. First, use algebra. You know, our course is called the calculus and algebra. Now algebra, using algebra to get B. These are all algebra. Using algebra to get B. You can do it in 10 steps. You can also do it in 2 steps, depending on how well you know about the algebra. Right now, you can do it in 2 steps because you know that matrices behave the same way. But that's only today. That's only today. Later on, when you learn that matrix do not behave the same way, you cannot do this so easily. Okay? Right now, it's simple. Transporting terms, 1 step. Dividing 2, 1 step. Another example. In this example, you will have 2 matrices X and Y and 2 other unknown matrices A and B. We need to find A and B. We have 2 equations. How do you find A and B? Simple. Simple. We will take 2A plus B equal X. We will do B equal X minus 2A in 1 step. I know in the first example, I did it in 5 steps, just to move a term, but not all the time. Okay, after the first example, after you learn about the matrix, you can do it in 1 step. So 1 step, you move 2A on the other side, and then you do a subtraction. That is substitution, not subtraction, substitution into 2B minus A equal y. And then you will have 2x minus 2a minus a equal y. Okay? And that will be 2x minus 4a minus a equal y. You see, I'm expanding. You see, I'm breaking the bracket. Breaking the bracket is property F and property G. Right now, I'm just gonna pretend that I'm working with numbers, but in fact, I'm working with matrices. Okay? And then I have 2x minus 5a equal y. I have 5a equal 2x minus y. And in the end, I have a equal 1 over 5 times 2x minus y. So I found a using algebra. Now, if I write all the steps down, that's gonna be very, very long. So here I'm just doing algebra. Another thing is to find b. Now, after I find a, I think I can find b. Okay. So to find b, I need to do another substitution, which is how do you find? I think I would solve it from here. From 2b minus a equal y, I will get a equal 2b minus y, and substitute a equal 2b minus y into the first equation. I will have 2 times 2b minus y plus b equal x. So 4b minus 2y plus b equal x. 5b minus 2y equal x. 5b equal x plus 2y. And b equal 1 over 5 times x plus 2y. Now here I use 2 substitutions. You can use other things, as long as you still obey all the algebraic rule within the matrices. So I found x and y. Okay? And then afterwards, I can do this substitution. Now you don't do the substitution right at the beginning. Right at the beginning, how do you find A and B? It's gonna write too long. So you solve it using algebra first, and then you plug in the numbers. Now I plug in the numbers like this. 12, 16, 22, negative 14, 10, negative 14, and then that is 5, negative 15, 20, negative 10, 10, negative 5, so 1, negative 3, 4, negative 2, 2, negative 1. Okay? Now in your homework, you have to write all these. Then you add. Oh, not add, subtract, sorry, subtract. Is that okay? Let's talk about it then. Let's talk about it. I think after finishing this, you must have some questions, right? Can I ask what you think about the especially the steps I performed in example 7? Sophie?
Yes. I don't have any question regarding this stuff.
You don't have
But actually I can I shorten it by for the second part, can I shorten it by skipping the third one?
which second part? This one?
Mm-hmm.
How do you shorten it?
Like, can I don't write the fourth one? 5b equals to x plus 2y, but I directly.
Yes.
Okay,
I
thank you.
think the thing is because it behaves the same way. So I think you just treat it as the but let me remind you, not you shouldn't be too carried away. Right now, yes, because it's just another algebra. You just solve another equation. You're just moving the terms, just multiplying, dividing. I think it's fine. You can do as short as possible, as long as you don't do anything wrong. And right now, you don't have anything to be wrong, right? Right now, with all the properties, you're just safe. Yes, you can. One problem that yes, thank you, Sophie. Now, one problem that I had in the past is that some students, when they have, for example, in this case, is that 5a equal 2x minus y, and then they express the answers as 2x minus y divided by 5. That one, I have a little problem, just a little problem. I don't want you to write this. Of course, I can understand what you mean by 2x minus y divided by 5. But if you search the textbook, you will not see one single place that a matrix is in the denominator and the numerator. The matrix is in the numerator and there is a denominator. It always is written in this way because technically we don't know what to divide. You can say, oh, divide is just to multiply. No, no. Let's steer like clear from the division. Don't do division. If you want to say divided by 5, you say multiply 1/5. This is why that in the textbook, you can never see this way. With numbers, it's all the same. With numbers, if you say, oh, the 5x equal 7, right? Is x equal 1/5 times 7 or x equal 7/5? They are the same. Because we just use them all the time. It doesn't matter. But for matrix, I prefer that you do not write a division here. We just don't touch the subject of division. Don't even touch it because we don't know what to do. Later on, we will learn carefully because we have another 2 operations, right? You can imagine what they are, right? We have this, what's next, right? So we will learn that later. Do you know what I mean? Okay. Let's come back. This alien subject right now looks like a very familiar friend. Okay, but it does have some unique things. Let me point out, it's not totally the same. Why do I say so? Why do I say so? The very small detail can still reveal something that this is matrix, this is not number. One thing that stick out, one thing that like run in my face is the dark zero. Dark zero. Now in in scalar operation, in numbers, you only have 1 0. That's 0. 0 is one number. That's 1. But we know that dark 0, there are many dark zeros. They are zeros of different sizes, zeros of different orders. And that is very unique. It's not 1 0. There are many, many different zeros. That's very unique. You cannot find that in numbers. Even now, in the past, we learned about numbers. The number we learn in integers, the 0, is the same 0 in real number. The real number 0 and the integer 0, they're the same 0, okay? We don't learn different 0. We just expand it and then add more numbers. But there is only 1 0, right? And also, if you look at, right now, here you can't see it. In this page, you cannot see it. Is that here, the previous page, this is also very unique. The identity matrix. Just now I said, oh, identity matrix is like 1 in numbers. Right now you don't see it in our property, right? You don't see, oh, where is I? There's no I. In the properties, you don't know anything about it, identity. That's because we haven't learned the multiplication, those things yet. Okay? When you learn that, you will see I. And then you will see another very different thing. Now, from between matrix and scalars, is that we also have a lot of different i's. We also have a lot of different 1, because I is like 1. And that is very special. So it's like, if we humans living on this planet, we have like, we have 1 nose and 1 mouth. And these are very essential features of us, right? But this alien that we just met, they also have noses and mouths, but they have multiple. They have more. So that is how you should, I think you should approach this subject, is to learn it as a different species. Is that okay? I think today's lesson will learn about the similarities, mostly the similarities between the alien, the matrix, and the numbers. And you will have 3 problems to solve in your homework. And then I hope that you can do well. You can do well. And in the following lessons, we will learn the differences between numbers and matrix. Is that okay? Do I make this approachable to all of you? Don't be scared. Don't be scared of this subject. Any question? Charmaine, any question?
No, I don't have any question.
You understand all the subject?
Yes, for now.
Okay, you know how to add, how to subtract?
Yeah, I think so.
You know how to present your answers?
Yeah, I can just follow your steps and do.
You can also know that a lot of things you have to write, and the steps perhaps can be very long.
Yes.
Okay. If you have that, you have psychologically prepared, then it's okay. Okay, then that's all then. Bye bye.